Okay, Miss James back here. Now we have our data table. We've got our sample calculation. We've got a graph. In this video, we're going to talk about doing some more advanced calculations. So from this graph, we figured out that M seemed to be, look, it's 221.5. It seems to be very similar to the resistance of one resistor. And from our analysis, we figured out that the total resistance equals N times the resistance of one resistor. So I'm going to go back to the table and I'm going to do a calculated resistance column. And it's also measured in ohms. And I'm going to say equals, you could go through and calculate by multiplying the number of resistors times the average resistance. You could put it into a calculator, but we're not going to do that. We're going to make a formula in Excel. So it's the number of resistors times the resistance of one resistor, which is actually 220. I'll have given you the value of your resistance in class. So it's the number of resistors times 220 for this lab. Now I can go back up here just like I did for average, make this into that black cross and pull it down. Shazam. Notice that the calculated resistance is pretty close to the average resistance, but it's not enough to say pretty close. We need to say how close, and to do that we do percent difference. Percent differences don't have a unit. They are equal to, typically, the difference between the two things you're comparing. In this case, we're comparing the calculated R and the measured R. So we're going to take the difference. We're going to say this guy minus that guy. And we're going to divide it by what we think it should be, which is our calculated. We need the parentheses. If you don't do the parentheses, you have an order of operations issue. So we push enter, and then we go back and we drag it down. We can also, under the formatting toolbar, do percent style. And we notice, oh, look how fabulous, such small percent differences we've got. That's beautiful. Okay. For accelerated, you might want to, in order to prove that your formula works, you might want to make a quick graph of the measured resistance versus the total resistance. So I'm going to do that really quick. I'm going to go into graphical analysis. I'm going to get a new graph. I don't need to save that. I've already gotten that. And I'm going to graph, oh dear. I'm going to graph these two things against each other. So I'm going to copy, I'm going to paste. Shazam. This one was the measured R total. In ohms, option Z. And the Y was the calculated R total in ohms. I'm going to push the A button so it auto scales. And then I'm going to fit a line to it. Now look at that. We're hoping that the calculated R and the measured R are going to be the same thing. That would be ideal. So the fact that the slope is that close to 1, it's only 1% off, right? It's only 0.01 out of 1 off of being exactly 1. So for accelerated in particular, you might want to do this graph and add it in. Why does that say that? Oh, I know why it does that. Copy and paste. And we're going to put that down to 30%. This is another nifty graph to have. Particularly, again, I would expect this of accelerated, not of foundational or of standard. Last thing we got to do, make sure we're okay with our sample calculations because we now have 2 more calculated columns. So how did we calculate this? Well, we said calculated R equals N times R1. So calculated R equals 1 times 220. So calculated R equals 220 ohms. For percent difference, we want to do the same kind of thing. Percent difference equals calculated R minus measured R divided by calculated R times 100. So percent difference equals 221 minus 220 divided by 220 times 100. So percent difference equals 0%. Miss James, does it matter if it's negative? No, you just want to know how far it is. You don't care which one is bigger. All right, guys, that was a longer one, but these are some more advanced techniques that you can use. Okay, bye.